Good morning, good evening, good afternoon, everyone. Happy Monday. Happy Monday. For all you out there, we got a really exciting little topic to talk about. So it's gonna be a good one, that's for sure. So excited for you to join us. Excited for you to check out what we're talking about, and ultimately excited for your commentary. As always, having a nice cup of coffee this morning. Good, feels good. We're gonna do an interesting topic today. That's for sure. We're gonna talk a little bit about spatial computing again, but we're gonna dig into a little bit about AI, machine learning, projections, computer vision, and what that means, and pull up some examples that are recently released from some of our partners, like Unity, like Microsoft, etc. So it's going to be a good one. With that, I think it's always best to hop on over to the screen share. But first, for those of you who don't know, my name is Rob Petrosino. I am an emerging tech leader, a futurist, and all around great guy. My role is to educate others on emerging technologies, but also push organizations to adopt technology that they may not be aware of. Synth Reality Podcast is here to help educate you, make you understand the topics that we're talking about, and be a thought leader on your own. But ultimately, want you asking questions. So if you're in any of the chats, always reach out. If you're struggling with the stream on LinkedIn or any other platforms, Twitch and YouTube are also live. Check out the socials down below and feel free to reach out. With that, we will transition over to the screen share. All right. So let's get into this real quick. So we talked about this last time. We talked about just the emerging technology of spatial computing, its ability to put something on my face and then see the world around me, augmented on the left-hand side with augmented reality. On the right-hand side, we're talking about virtual reality. Now, if you were here a couple LinkedIn live or YouTube or Twitch lives ago, we had this top portion filled out over here, but we did not have these two bottom ones. These two bottom ones we talked about briefly, digital twins. We're going to dive into that one at a different time, but think of that as a real world replication of something virtually. It could be a cup, it could be a warehouse, it could be anything along those lines, but we're going to talk about machine learning a little bit, and more importantly, artificial intelligence as a whole, and then dig into computer vision and why computer vision is so cool. So let's talk about AI versus ML, and we'll talk about iRobot and general intelligence real quick. So artificial intelligence is the big term. Okay, that is the biggest umbrella. Just like spatial computing is the umbrella term that we use for AR and VR, artificial intelligence is the larger one. The one below that is machine learning. Okay, machine learning is, there's literally hundreds now of different methods of training machine learning algorithms, but it's a subset of AI that uses algorithms trained on data to perform complex tasks. So the key portion of there is trained on data. Okay, so there's a fantastic term that goes around the AI and ML world. It's good data in, good output, right? Bad data in, bad output. So making sure that that data is really vital and important and meaningful and useful to people that are gonna you know use the machine learning algorithms, if you will. We're going to step away from neural nets and deep learning. Deep learning is one of those black box type of areas that is interesting and somewhat undefined, if you will. We're not exactly sure what's happening. And neural nets is the ability to connect different neural recognitions together. We're going to talk a little bit about neurons later on. But so AI, big umbrella term, machine learning, training an algorithm based off of a data set specifically so that it is meaningful and valuable. Okay, and that meaningful and valuable part is always something that we talk about, something that I say a lot of. Meaningful and valuable means that the user is getting something that is important out of this, and it is actually useful from their day to day. So a really, really easy example, ChatGPT is a natural language uh, uh, machine learning algorithm. People want to perceive it sometimes as general AI intelligence, which is completely different, but it's trained on natural language to produce outcomes that are similar to a human's response, which is very, very cool. So, AI umbrella term, ML subset. What's iRobot? So there was a term long, long ago called general artificial intelligence. What general artificial intelligence actually does is what you would see from iRobot the movie or Ex Machina the movie, where you are talking to a robot and it has full intelligence and understanding of what you're saying, and it thinks or replicates like a human. We are not there yet. Um, One of our big barriers in that is consciousness. We barely understand how consciousness works in humans, so expecting us to replicate that virtually or in an AI program or robot is a little bit tough. Okay, so there's some barriers there. But let's take a layer down just to wrap this up nicely. Machine learning is a computer system uses algorithms and statistical models to analyze and draw inferences from patterns of data. So not only is it trained off of that data, but it's going to have a complex task that it pushes out, and that adaptable model analyzes and draws inferences from patterns in that data. Very easy machine learning example that you may have used if you use Chase or Bank of America or TD. It will auto categorize your transactions into different items, whether it's food, whether it's gas, whether it's travel, etc. That is a very simple machine learning program that draws inferences of all the transactions they have at TD or Bank of America, and then labels it appropriately. So that is machine learning. It's going to analyze and draw inferences of it. So the long-term projection, self-admittedly, these projections are from September of last year. This is pre-ChatGPT launch, which is kind of crazy when you think about it in that regard. But they were saying by 2029, about $1.3 trillion in estimated market size. Growing, and it's kind of ridiculous, right? I call out some things related to ChatGPT. They had about 4 million users in a single week, but 9 out of 10 businesses are basically saying that they're going to make an investment in AI. And again, this was pre-ChatGPT projections, pre-Google Bard projections. So now that we have Microsoft and Google, for those of you who don't know, Google Bard is Microsoft's is the competition to Microsoft's ChatGPT / OpenAI's ChatGPT. They're the ones that are dueling around for this. But basically, this projection is going to look like a hockey stick very, very soon when they bring out the new ones, which is pretty interesting for sure. Moving on, just digging into a little bit more of the machine learning, you can do a lot, but ultimately you need to understand business goals. You understand what a scalable architecture is, understand a crawl, walk, run approach to any machine learning. That means when I'm starting out, I'm focused on a very core task, and then I can expand from there. If I try to boil the ocean, it's not going to work well. For those of you that are on any of the streaming platforms now, let me know what your thoughts about Crawl, Walk, Run, or tell me a story about how Crawl, Walk, Run was not the process you used, and how terrible it went. But on the left-hand side here, this visualization is actually neurons of the brains reaching out and touching each other. This was actually from Elon's Neuralink project, and showing how the neurons of the brains actually will reach out to each other and try to form connections. So there's a lot of different types of machine learning. There's open source, privatized. There's every version of it underneath the sun, from Hugging Face all the way through, OpenAI, etc. There's going to be a lot of investment in this area. So making sure that you ideate, then create, refine, and deploy. All right, ideate, understand what's going on, create a good example, proof of concept, refine that concept, and then deploy it so that it's meaningful and valuable to your users. That is what machine learning is all about. When we talk about a subset of machine learning, we're talking about specifically today is computer vision. So computer vision is artificial intelligence that enables computers to derive information from images, videos, other outputs. Just depends on what you are feeding it. When you look at this type of information that gets passed through, it is specifically done in bounding boxes. And we're going to talk about bounding boxes in a second, but what we're asking the computer to do is bound different images or different information in boxes so that it understands what it's looking at. So AI is going to derive information from those images, specifically what information you want to see, which would be based on the data set that you fed that machine learning algorithm to understand. So what do examples look like, right? Here's a very, very quick computer vision machine learning example. What we're doing here in A, B, C, and D, we're identifying objects within a room. Okay, pretty straightforward, right? I'm understanding and lining up and seeing these are pictures, potentially these are, this is a photo, these are different books that are on the wall, this is a table, etc. And what you're actually, these little numbers that are next to these that are a little bit hard to see on screen share, they're actually percentages. And what we're saying was rough percentages of accuracy. Based on the data machine learning set, we believe that this is the rough percentage likelihood that this is an actual object. So in that computer vision thought process, what you're actually doing is that you're saying, hey, I am, as a machine learning system, I think that based on the data set that you fed me, this is a plant. That is what we're talking about here. So to get that done, what we actually wind up doing is feeding in data sets, and a bunch of different types of data sets are actually out there. Data sets can be real world data sets, or they can be synthetic. Yes, Kevin, this is a plant. So for those of you that are not over on Twitch, head on over. We got a live chat going on there. Feel free to check it out. So the data sets that we do get are really, really interesting because you can do it from something that's in the real world for computer vision, or you can do something that's not real. Okay, it's kind of a ridiculous term, but not real data would be called synthetic data. And you can use synthetic data because there's tools like Unity who have synthetic data generation tools. So what this actually is the ability to see and generate synthetic data or virtual environments that have a ton of information in them that you can then train your machine learning model off of. So this would be a trained bounding box model here. It's identifying different things that are in here. We need more coffee. Identifying different things in here, but this is all virtual. So this is not a real world photo. This is not a real world video. This is actually completely artificial. So just like Avatar, okay, that was made on Unity, this is actually done in the same regard, right? So this 3D model is actually able to put fake Ziploc, Nature Valley, Pringle cans in here, and then segment and bound them, right? So we get this 2D bounding box, which is super exciting, right? That's the one that we were talking about here. We can actually do instant segmentation, which is a different type of segmentation of information within a scene. And then we could actually do 3D bounding boxes as well. So this model, right, what Unity is providing here is the ability to create a fake data set, and that fake data set then can be training the machine learning model, which is really, really interesting, because when you think of how you would traditionally have to get machine learning model information is by taking a ton of photos and or videos and accessing it. So now you don't have to do that. And it could be anything. It could be synthetic homes. It could be, store shelves. But the one that I find most interesting is synthetic humans, right? So for academic use cases, you can actually go in and use synthetic humans to generate and build what a person would look like. And when you have this person, you can do a lot of different things with them, such as what Microsoft just recently released, which is called DigiFace. 1 million digital face images for facial recognition. So what's actually interesting is they created these digital twins of humans, and the computer vision uh, model that's trained off of this, so the machine learning model that's focused on computer vision, is able to use this data set for facial recognition of 150% completely fake people. They don't exist. They're not real people. So the synthetic data set, or SynthFace, okay, actually allows you to train a machine learning model on a predictive outcome of facial recognition based on information that is completely fake. Okay, so think about the progression here. We don't have a ton of blockers now for any type of experience that we want with a machine learning system. We can go and make a fake data set, train off of that fake data set, and then deploy that directly into the experience, which is insane when you think about it, right? There is a lot of different information that can be happening. There's a lot of different pieces of training that can happen. And because of all of this, we can actually just do it directly on a fake data set. So that is the most interesting part about this, is that nothing has to be real anymore. Kevin, appreciate the follow, by the way. If you got questions, you feel free to let me know. Anyone over on the LinkedIn side or the YouTube side, hop on over to Twitch. You're going to get a much better streaming experience, I promise. So the really interesting thing about this whole experience is the fact that you're able to engage, develop, deploy a synthetic data set, right, using Unity or DigiFace. That synthetic data set can then be training a machine learning model to give you a predictive outcome. Okay, that in and of itself is some of the most interesting technology that's in the market right now. And the reason for that is because you can do virtually anything with machine learning. So if I want to talk about transactions on my credit card all the way through creating virtual environments, I can do all of that directly on a fake data set, and I don't have to aggregate that information anymore. And if I'm not aggregating that information, I'm much more likely to reduce dwell time, or the time that it takes for a machine learning model to be up and running, because I have a synthetic data set, right? And the reason that these tools are fantastic is not only because you do it in 2 dimensions, but you can do it in 3 dimensions, right? So if I have that ability to rotate things in 3 dimensions, now we've absolutely gone in a completely different direction when it comes to our machine learning examples. So that is today's Synth Reality Tech Talk. We hit a lot today. Okay, we talked about a lot. We talked about spatial computing. We went down and talked about machine learning and artificial intelligence and what general AI is. We went all the way through what the projections are for AI and ML. We talked about neurons, and we talked about computer vision specifically, and even down to bounding boxes and how that impacts our different predictive outcomes, whether they're 2D or 3D bounding boxes. And this is just some of the technology that's out there right now. So if you're interested, subscribe. Make sure you check out the socials below. If you have questions, I'm always here. Feel free to reach out, chat, and let me know what your thoughts are. And I appreciate your time spending it on the Synth Reality Podcast. We have a lot to talk about. We're not going anywhere. There'll be more coming out soon. So with that, I will see you guys on the other side.